Hey guys, welcome back to my channel. Thank you very much for joining me. Here we're going to be explaining the concept behind inequalities. So let's get right into it. So here we have the four basic signs. Less than, as we see here, x is less than 2. So we need values of x that are less than true to make this inequality true. Here we have a second sign that is the opposite of this one. So we say that sign is known as a greater than sign, where y is greater than 4. So we need values of y that are bigger or greater than 4 to make this inequality true. For this sign, you see it resembles the first one. So we say it's less than or equal to when it's being compared to when two things are being compared. So here we say x is less than or equal to 4. For this to be true, we need values of x that are equal to 4. So it can be 4 or less than 4. Okay? So we see the last sign here is similar to the second sign, apart from the equal sign that's at the bottom of the greater than sign. So this sign here means greater than or equal to when you're comparing two things. So y is greater than or equal to 7. So here, to make this true, we need values of y that are 7 and above. Okay? So for inequality, we can be asked to graph this on a number line or to graph it on a Cartesian plane. So you have to know the regions that you're going to be shading for each of them. Okay, so I'm going to be putting this paper away for now and we're going to be talking about it. So the first one we had was x is less than 2. Alright, so if you are asked to represent this on a number line, you know you're basically going to be drawing your number line. Okay, you can choose to put the exact number you see here, or you want to number, are you going to number it from 0 positive on the right hand side, 0 positive negative on the left hand side, or you just, or they may give you a number line for you to fill it out. However it is, it doesn't matter. So I'm going to start from 0 and I'm just going to identify the point that I have here instead of filling it out. So they say x is less than 2. To represent a number line, we need to know what are the values that are less than 2. As you can see, it says less than, that means 2 is not a part of the answer. So we're going to be identifying the number we see in the inequation, which is 2. And so less than 2 will be all of these numbers on your left hand side. So you're going to be from 1, 0, negative 1 down to negative infinity. All right. So before I get into the others, I'm going to show you a little way how to remember these signs. So I'm going to draw them again. So that's less than. So the opposite sign will be greater than. So less than, equal to, greater than, equal to. So for the number line region, you basically know that once you see less than, the number you see on the opposite side of that sign is not a part of the solution. So we will not have a shaded circle here. It will be an open circle. So we're going to use the open circle to identify this one. So open circle, and the sign, where the sign is pointing, it will tell you where to point your arrows. So it will be going this direction. All right. So open circle again, pointing greater than, you're moving to your right. When it comes on to less than, equal to, and greater than, equal to, remember, as I was saying to you before, that once you see the equal sign beneath it, that means the number you see on the other side is a part of your solution. So for this one, we will have 4, 3, 2, 1, down to negative infinity. All right. So let's get back to what I was saying. So for this one, it says less than, equal to, because this was our less than sign. So draw our circle. It's going to be shaded. And it'll be pointing in this direction. For greater than, equal to, we're going to be drawing our circle. It's going to be shaded, pointing to your right. That means once you see the circle shaded, that means the number you see is a part of the solution. For example, if x is greater than or equal to 1, draw your number line starting from 0. I'm going to identify my 1. In this case, 1 is in the solution as it says greater than or equal to 1. So starting at 1, I'm going to be shading my circle because 1 is in the solution and it says greater than, so I'm going to be going this way. All right, if you don't remember what these signs mean, just look at the arrow and it's a number line and see where it's pointing to. Not arrow, look at the sign and see where it's pointing to, and it will give you a great idea of what I'm talking about. All right, so let's move on to when you're asked to represent it on a graph. If you have a Cartesian plane, right, and they say, for example, x is less than 4. And I can say less than because I established it earlier in the previous slide. So x is less than 4. On your Cartesian plane, you don't have the option of using the icons I showed you just now, where you draw the circles and you point the arrow and whatever like that. You don't have the option on a Cartesian plane. So what you're going to have to do, basically, they're going to tell you to shade the region. All right, and to shade the region, guys, you basically need to know where is x equal 4. That's the first thing you can find. Where's x equal 4? So we know that this is our x-axis, that's our y-axis, right? I'm going to be our positive x. So what we can do, we know here is the origin, so that's 0. I'm going to go the short method. I'm going to put in the 1, 2, 3. I'm going to identify 4. So my 4 is right here. Similar to the number line, you need to understand that once it says less than 4, 4 is not in your solution. So what we normally advise the students to do, I'm going to be drawing the signs again on this side and explaining that part to you, is to use either a dotted line or a solid line to represent where your starting point basically is, or where the number indicated on your right and in the equation is. So in this case, we have a less than sign here, so we're going to be using broken line. So less than or greater than, we use broken line. I want to say dotted line, up to you. For less than equal to and greater than equal to, we use a solid line. All right. So in this case, it says x is less than 4. Again, less than or greater than, we use broken line. So we're going to go where 4 is. Use broken line right there. And to shade the region, it says less than. So numbers less than 4 will be 3, 2, 1, 0 down to infinity. That's the negative region. So all of this region here represents your solution. Okay? So once you understand the concept where you know that less than or equal means less than, or greater than means a broken line, and less than equal to, greater than equal to means a solid line, you are good to go. So let's explain. Let me show you a region where, what did they say? Y is greater than x. Yeah, y is greater than x. Let me just greater equal to, since we have that already. Y is greater than equal to x. All right, as I was saying to you, when you're solving, you can always pretend that this is an equal sign. For example, if you're going to be drawing a graph, so we know y equal x is the line that goes like this. That means when x is 0, y is 0, x is 1, y is 1, x is 2, y is 2, x is 3, y is 3. The list goes on, so y is equal to x. All right, but in this case, it says y is greater than or equal to x. Looking at this line, y equal x, and it's not drawn to scale because a little bit is off here, but it's fine. So this line is the line y equal x. All right, so it says greater than or equal to. 1, we know it's greater than or equal to, so it has to be a solid line. So already I'm correct here with my solid line. If it was not greater than or equal to, but greater than, you're gonna have to do broken line as we did above here. But in that sense, guys, y is greater than or equal to x. Which region of your graph represents greater? Is it above the graph or below the graph? It says greater, so we know it's going to be above the graph. All right, so all of this region, y is greater than or equal to x. Okay, so if you pick any point here, let's say you pick a point right here, and that point could be 1, 3. Let's say it's 1, 3. Let's say it's 1, 3, guys. So let's say this point here is 1, 3. The value of y is 3 because it's on the y-axis, and that's xy point. When y is 3, we see x is 1. Y is greater than or equal to x. Means it can be bigger than x or it can be equal to it. So in this case, y is 3, and you see that 3 is greater than 1. See that? But it's greater than or equal to. So it's 3 is greater than or equal to 1. If I had chosen this point right here, let's say that's 1, 1. 1, 1. Here it proves true because y is greater than or equal to x, meaning that y can be 1, x can be 1 because it says equal to. So again, it is also true. With that said, any point on this line and above the line will be true for this. And if you understand this concept, I don't have to explain the greater than part, the less than equal to part, as you will know where to shade. If you have any question, feel free to drop a comment in the comment section and I'll be happy to respond to you. This was a requested video, so I have another part, another aspect of it to do. So stay tuned for that one, and I'll see you on the next.